Hello and welcome back to my channel. Today we will be talking about the powerful detection techniques used to decode wideband frequency modulation or WBFM signals, including PLL and the Foster-Seeley Discriminator, and finally a comparison table to help you choose the best method for your design, whether it is for learning, simulation, or real-world application. So in this lecture, basically we will see brief introduction to those methods, and in the later lectures we will discuss each method works and they either generate or detect the wideband frequency modulated signal. WBFM detection methods are also of two types. The first type is the basic and analog techniques, and second type is the modern and digital friendly techniques. Basic and analog techniques include slope detector, balance discriminator or dual slope method, Foster-Seeley discriminator, and ratio detector. Modern and digital friendly techniques include Quadrature FM Detector, Zero Crossing Detector, and Phase Lock Loop Detector. Now let's see how we can detect frequency modulated signals. Once frequency modulated signal is received, it must be demodulated or detected to recover the original message signal. Detection works by converting frequency variation of the carrier back into the voltage variation that follow the original audio or data signal. There are several techniques to do this, ranging from simpler analog circuits to precise digital systems. Let's start with the most basic method. The first one is the slope detector. This is the simplest form of FM detection. It uses a tuned circuit slightly offset from the carrier frequency, which converts the frequency into the amplitude variation due to the slope of the resonance curve. These amplitude changes are then passed through an envelope detector to extract the original message signal. Some pros are extremely simple design, great for demonstration and teaching, easy to understand and build using basic components, useful for illustrating FM demodulation principle. Some cons are nonlinear output easily, especially over wide frequency swings, highly sensitive to AM noise, requiring careful shielding, not suitable for modern and high fidelity applications. Next is the balance discriminator or dual slope detector. This method improves on the slope detector by using two tuned circuits. One is tuned slightly above the carrier frequency and another is slightly below it. As the input signal frequency shifts, the two output changes in opposite direction. By subtracting one from another, a more linear and noise reduced message signal is obtained. Some pros are improved linearity compared to a single slope detector, simple to construct with minimal added components, and provides better output symmetry. Some cons are they are still sensitive to amplitude noise, requires precise tuning of both resonance circuits, limited dynamic range and accuracy compared to modern detectors. Next is the Foster-Seeley discriminator. This classic method uses a center type transformer to split the FM signal into two phases. The two diodes rectify the signals, and the phase difference between the primary and secondary windings create a voltage that varies with the frequency deviation. The voltage is proportional to the original message signal. It is one of the most popular FM detectors used in early analog FM receivers. Some pros are good linearity and effective for standard FM applications, reliable performance in analog systems, provide high sensitivity when properly tuned. Some cons are require amplitude limiter to avoid distortion from FM noise, vulnerable to circuit imbalance which can affect the accuracy, slightly more complex than slope-based detection methods. Finally, let's look at the ratio detector. The ratio detector is a modified version of Foster-Seeley circuit that includes a special capacitor arrangement to keep the total voltage across the diode constant. This clever trick makes the detector immune to amplitude variation, eliminating the need for external limiter. The output is derived from the ratio of voltage across the diode, which reflects the frequency changes in the FM signal. Some pros are it rejects the FM noise without needing a limiter, robust and reliable for analog broadcast receivers, good linearity and wide dynamic range. Some cons are this is slightly more complex than Foster-Seeley discriminator, requires precision tuning of components, may be less adaptable to integrated or digital systems. Now let's look at the modern detection techniques that are used for the detection of the FM modulated signals. First one is the Quadrature FM Detector. In the Quadrature FM Detector, the FM signal is split into two parts. One path is phase shifted by 90 degrees and another remains unchanged. These signals are multiplied or XORed in digital form. The result is passed through a low-pass filter to recover the original message signal. This method is widely used in the integrated FM receivers, such as those found in TVs and mobile devices. Some pros are highly linear, suitable for high performance application, well suited for IC implementation, compact and cost effective in modern FM chipsets. Some cons are requires precise 90-degree phase shifting, especially critical at low frequencies. Performance degrades if frequency accuracy is off, may require careful design of analog phase shifting network. Next detection technique that we have is the zero crossing detector. The zero crossing detector is a simple and digital friendly method. The FM signal is first converted into a square wave using a hard limiter. Every time the waveform crosses zero, it triggers a pulse from a monostable multivibrator. The rates of this pulse, which corresponds to a frequency, is averaged to reconstruct the message signal. Some pros of these methods are simple and effective for digital system, easily implemented in software or logic circuits, provides good accuracy with clean input signals. Some cons are highly sensitive to jitter and input noise, requires clean zero crossing for reliable output, less suitable for noisy or analog heavy environments. Next detection method is the PLL detector or phase lock loop. The PLL detector is the most advanced and accurate method of FM demodulation. It uses a phase detector to continuously compare the input FM signal with the VCO output. The resulting phase difference generates a control voltage that adjusts the VCO to track the incoming frequency. The same voltage serves as demodulated message signal. Some pros of these techniques are exceptional linearity and very low distortion, excellent noise rejection even in the crowded RF environments, ideal for digital systems and software defined radios or SDRs. Some cons are more complex design requiring careful low filter configuration, requires stable components for precise operation, can be more power intensive than simpler methods. And that wraps up the key FM detection from simple analog circuits to advanced PLL system. Next up, we will put this side by side in a comparison table to help you choose the right method for your project. Now that we have explored the methods of generating and detecting FM signals, let's compare them side by side. This will help you decide which method fits your application, whether for learning, prototyping, or professional use. Now let's compare the FM detection methods. First we have the slope detector. It has poor linearity, poor noise immunity, cost is low, it is basically used for teaching and basic concepts. Next we have dual slope discriminator. It has greater linearity than slope detector, but it has very low noise immunity and cost is also low. It was used in early analog receivers. Next we have the Foster-Seeley method. It has greater linearity than compared to previous ones, and it has also greater noise immunity than the previous two. The cost is medium and it is used in analog FM radio with limiter. Next we have the ratio detector, which in terms of linearity and noise immunity is better than the previous three. It has a medium cost and it is used in analog broadcast receivers. Next we have the quadrature detector. It offers greater linearity than the other four other methods. It has lower noise immunity compared to Foster-Seeley and ratio detector. The cost is low and it is used for frequency modulation, IC and TV systems. Finally we have the zero crossing detector. It has the greater linearity and the noise immunity is very low and the cost is also low, and it is used in the digital systems. Finally, we have the PLL detector, which offers better linearity and noise immunity than the other ones. Its cost is medium and it is used in modern SDR and digital FM. For frequency modulation detection, PLL based systems offer top tier performance, especially in noisy environments and SDR application. Radio and quadrature detectors are great for analog and integrated designs, while slope detectors are mostly educational. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section, and don't forget to hit the subscribe button. See you in the next one.